already used, but we're going to use them in a little bit different way now. A ratio is an ordered pair of non-negative numbers which are not both zero. And we know how to denote ratios as A with a colon, B between it, which is just read A to B, where A is the first number and B is the second number. And then two ratios, A to B and C to D, are equal if there is a positive number C such that C is equal to little c times A, or D is equal to the little c times B. And so that's something we've really seen before. I'm just going to come up here to the top of the paper, because if you say A to B, that's like A over B, and C to D, that's like C over D. And if those two are equal, we can get C over D by multiplying the numerator and denominator by the same number, and that's the little c that they're talking about down here. So we're multiplying A times little c to get equal to C, and that's what that is right there, and then B times little c to get D. So very easy example, if you have 1/2 is equal to 2/4, we know that that's true because we can multiply the numerator and denominator by 2 over 2, and that would be like our c's there, and we can get an equivalent fraction that way. This little c is called constant of proportionality, which we'll talk about later. And then a ratio of two quantities. For example, 5 miles per 2 hours can be written as a rate, and that would be like saying 5 miles per 2 hours. But then we could divide the numerator and denominator by 2 and say that's 2.5 miles per 1 hour. And they call that 2.5 the unit rate. Okay, so looking down at our first table down here, this example is we're taking statistics from a class where they were practicing passing back papers, and when they passed back the papers, they timed them, and they found out that the first time that they did it, they weren't as good, and they passed back 24 papers, and it took them 12 seconds. Then the second time they tried it, they passed back 24 papers, and they improved. They went to 11 seconds. Then again they did it, and they improved another second, so they passed back 24 and 10. And then the last time they passed back 24 and 8 seconds. So what that says is practice probably helps a lot. But we want to look at the ratio of number of papers passed to time. So in the next column we'd say that would be 24 to 12. Or you could say 12 to 24. I'm sorry, 24 to 12. You can do it either way. 24 and put the word 2, 12 in between. And for the second one, we could say 24 to 11. And we can write it either way. And for the third one, it would be 24 to 10. And for the last one, 24 to 8. And if we reduce some of these ratios and we divide it out, of course, a 12 out of both the 24 and the 12, we would end up with 2 papers per 1 second, or just 2 papers per second, and we would call the unit rate 2. Then if we reduce the next one, we can't because there's no common factor. But if we divided out an 11 out of both of those, that would be approximately 2.2 papers per second. I don't need to use the word per. And then for the next one, if I divided a 10 out of both of those, that would be 2.4 papers per second. Because we want our denominator to be 1, so we can write it as a unit rate. Here the unit rate in the second one would be 2.2, the third one would be 2.4, and if we divide an 8 out of both of these, that would be 3 papers per second. So the unit rate would be 3. So when we compare these and we look, we say that the fastest rate there would be 3. So they improved, and they were able to pass back 3 papers in 1 second, where when they started they could only pass back 2 papers each second. But that would be their speed in papers per second. Okay, the next example we're going to look at is looking at our class by gender, and I did actually break down each of the classes in our first period. We have 4 boys to 18 girls, and so that's going to be 4 to 18. And then we had 11 boys in second period to 7 girls, and then in third period we had 8 to 5. Then in fourth period we are even, 8 to 8. And then in fifth period we've got a lot more boys than girls this time, and you can tell by the rambunctiousness of that class. And then down here I've got all of my classes. There's 61 boys to 58 girls, which you find out is actually pretty even. And so it ends up kind of balancing each other out, even though I've got a lot of girls up in this class and a lot of boys down in this class. Ends up pretty close, almost 60 to 60. But we want to know, well, what would period 7 be? So of course we could just add all these up and say 15, 23, 31, 50. So that means if I take 50 away from 61, there has to be 11 boys. And then about 25, 30, 38, 46. Subtract 46 from 58. That makes 12. So here we've got 11 boys to 12 girls. So when we look at this, some questions. Are the ratio of boys or girls in the 2 classes, or not in the 2 classes, in the 6 classes, are they equivalent? Well, they're not, of course. And what do these ratios tell us? Well, in here we have more boys, or more girls than boys, definitely. And these are small. Let's see, this one's smaller than the whole all-class ratio. This one's larger than the all-class ratio. This one's larger. These are close to being equal to the all-class ratio. And then this one's larger than the all-class ratio. And the last one is pretty close to being equal. It's a little smaller than the all-class ratio. So we could actually look at these ratios and break them down and see which ones are closer to being equal. But when we're comparing boys to girls, we can see that they end up balancing out towards the end. Okay, so the last example, we've got Value Mart is advertising a back-to-school sale on pencils. A pack of 30 sells for $7.97, whereas a pack of 12, the same brand, costs $4.77. Which is the better buy, and how do you know? Well, if we're going to compare these by ratio, rate, and unit rate. And if you ever look at Kroger or any grocery, I think Meijer and Walmart do the same thing. When they have their prices, a lot of times they'll break it down and they'll show you the unit rate, which is, the cost per ounce or the cost per pound. But if you want to pause the video and try to break these down yourself and see if you can find it, that'd be great. And then we'll come back and you can turn the video back on. We can work them together. All right, so for the ratio, the first one, it's $7.97 for every 30 pencils. I'm just going to put PEN. And then if you wanted to look at that for 60 pencils, it would be double that, so that would be $15.94 for 60 pencils. Or we could divide out the 30 and get for one pencil, and divide the 30 out of the $7.97. If you divide both of those by 30, you end up getting approximately, let's see, so for the rate, that would be $7.97 out of 30. And if you divide both of those by 30, you're going to end up getting 0.27. So that's how much cents, because it's $0.27, which is 27 cents per pencil. Per one pencil, but we'll just say per pencil. I could put it over one, but I could also just call it per pencil. That means the unit rate here is going to be 0.27. And if I do the other one, that's going to be $4.77 for every 12 pencils. And if I doubled that, that would be, no, actually I multiplied it by 5. And that way I can compare it to 60 pencils. So if I multiply that by 5 and get 60 pencils, I can multiply 477 by 5, and I can get that that's $23.85 for 60 pencils. But then I could also divide out the 12 out of both of these, and if I have 477 over 12, divide out of 12, and divide out of 12, that's going to be 0.40, which is 40 cents, or 0.4 of a dollar per pencil. So the unit rate there would be 0.40. So in that case, if we want to know which is the better buy, this one's going to be the better buy.